All right, so welcome everyone for this eighth pack meetup. Yes, it's the eighth one. Today, after 2 months and more of lockdown, we've been trying to organize those meetup every week. So that's quite a rhythm. So like I mentioned last week, this is going to be not the last one because we still have one pack meetup planned next week. I will reveal the topic of this last pack meetup soon, at least before the conclusion. You will see it's a quite interesting topic, and I'm pretty sure that you will appreciate it. It's been, in fact, a topic submitted by one of our attendees of last week, who was there, and we picked, in fact, two topics from the last pack meetup, one for related to today, and the one for the last pack meetup. So I told you that we're going to select one from Neotys perspective, but we were quite cool because we selected also a topic that you wanted to hear about. So the last pack meetup, you will see the theme is quite awesome. Thanks everyone to join us again. So for that pack meetup, we have several speakers. I see that part of the speakers are not showing it up yet. So at least I will start to introduce the three speakers that are officially here tonight. So I will start with a partner from our side. If you've been following the pack, you've been seeing him presenting at least at the virtual pack, our first virtual pack. It's Zach Call, live from LA, representing Whiteblock. So hi, Zach, how are you?
Hey, doing well. How are you doing?
Like every Wednesday, pretty cool. And especially in France, tomorrow it's off. It's going to be like a bank holiday, and they're going to have a long weekend. So it's like almost the last mile before enjoying a few days of just nature and family and whatever.
Yeah.
All right.
Yeah.
Otherwise, we have with us another partner, and I'm super happy to have someone from Dynatrace. David Jones has been following him on Twitter. He's doing a lot of awesome, great stuff. And I never had a chance to have him on board with us. So it's the first time, and I'm so happy to have David with us. So, hey, David, how are you?
Hey, how you doing? I'm happy to be here. Thank you very much for having me on. Really appreciate it.
It's awesome. And where are you based, David, by the way?
I'm based out of Toronto, Canada, where finally the sun has come out.
Toronto, Canada.
Is
So at the moment, I'm watching with my wife, Hands Made of Tail. So Canada seems like liberty compared to the rest of the world. So I think
yeah.
You're speaking from the freedom country. It's pretty awesome.
We're doing pretty well.
And how are things going in Canada? How is the lockdown?
You know what? It's being lifted kind of slowly. Canada very much took a science-based approach to this, so everyone's being very cautious about lifting the lockdown. So other than that, it's slowly starting to get lifted. They're being very, very cautious.
Yeah. So in France, they open up, but they're still cautious. But they open up because business. Yeah, if you want to relaunch the economy, you have to do something. This is what they decided in France, at least. Otherwise, we have a special guest. So when I had the theme about blockchain, by the way, I didn't say it, but we are going to talk about blockchain today. So if anyone has been heard about blockchain, because if you have been working with traditional web applications, probably blockchain seems quite weird for you guys, but here we're going to reveal all the secrets. And when I mentioned to Zach, I say, hey man, we're going to talk about blockchain, I said we need someone that he knows about blockchains, and he's been involved in several projects. And he said, hey, why don't we invest Preston? I said, oh, okay. So I never had the chance to interact yet with Preston, and it's been an honor to have you on board, Preston. So it's pretty cool to have you. So hi, Preston, how are you today?
Hey, I'm doing great. Thanks so much for having me. Pretty excited to be here. I love talking about this stuff. So I'm based in LA, just like Zach, and we're hanging in there for quarantine, but can't complain. Life's pretty good.
So at least you have the sun. You
Yeah.
have the California weather. So it's similar to where I live, so south of France, but with the California attitude, I guess. Otherwise, we have a good friend of ours. He is animating Perf Bites shows. He's been on the pack several times. So it's Mark Tomlinson. So it's an honor to have you, Mark, again back to our pack meetup. It's great to have you. At least I think we're going to at least entertain all those folks during 1 hour and 30 minutes. Mark, how are you today?
Good, hanging in there. It's nice to see all you guys. Zach, great to see you again, man.
So how is Philly going on?
Philly is nice. Philly is windy. We had some sort of a storm. I guess a cyclone hit India, but there was some other thing that hit North Carolina over here. I don't know. It's kind of strange. But yeah, we're good. It's and I have a dog that's probably going to start barking sitting on the floor behind me. So we adopted 2 dogs, which is kind of fun.
Cool. So I guess if those dogs want to learn about what is blockchain, then it's the right moment to have them listen to what we're going to talk.
You don't need opposable thumbs in order to learn blockchain. That's one of the main learnings, I think, today.
Otherwise, we have other guests that should probably join us later. They announced that they have a busy schedule, so they'll probably join us later on. So I suggest that we start. So I'm pretty sure that part of the attendees that has been involved in lots of load and performance testing, I think it's really important for them that we are defining what is blockchain. With the help of Zach, I've been involved in mainly Ethereum 1.0, and I know that Preston is working on the version 2.0. And I'd like to have Preston to start explaining us about where you see blockchain, because if you're working on the new stuff, you probably know a bit more than, and also I'd like, first of all, to remind to all the ones that are connected today that blockchain is not cryptocurrency, guys. It's other stuff. So Preston, I'll let you start, and we're gonna then, of course, discuss. It's an open discussion approach. So Preston.
Yeah, this is a great question, and I really love answering it. There are so many different use cases for blockchain technology. Specifically as an application platform, it can really enable a lot of different use cases, a lot of different solutions for real world problems. But even at the fundamental, cryptocurrency level, it can service peer-to-peer money, you facilitate these kinds of transactions that we deal with on a frequent basis. So, sending money between friends or anything like that, that's a pretty common use case, and kind of the most common one that we see with things like Bitcoin. And then you have Ethereum, which has a value too. And on Ethereum, we have all these, stable coins and sort of things. And the cool part about Ethereum is that it's the application platform based on the blockchain principles, where you can develop some trust minimalized application that runs on a platform that's never goes down. So that's really powerful. I think what was the second part of your question? Was it where this is going, or?
Yeah, because I think most of the features that were part of Ethereum was mainly transaction based or signed transactions, things like this. I think now I heard that there were more and more features that would more be designed for approval, workflows. And I think I'm thinking loud now. Maybe insurance company will be delighted to use those type of things. So, do you have any insights on what is the new version of the new generation of things that will come?
Yeah, I mean, you gave a couple examples. So there's, these decentralized insurance groups that are coming together. One of the most exciting things about Ethereum is to be able to create what's called a DAO, or a decentralized autonomous organization. This is like a company or a group of people that doesn't have a dedicated leader. It's all sort of done collectively and in a transparent way. So with that kind of, application, you can build things like a decentralized insurance, or have some kind of governance policy about maybe how a project should be run. You have a DAO that can vote, allocating funds or whatever, what have you. I think the future going forward, there's going to be a lot of use cases that have to do with real world ownership. So things like identity and property ownership. It's still today very difficult to maintain records of property ownership, especially in countries that are going through conflict or something like that. They may end up fleeing from that area to come back years later to find someone has taken over their house, and they don't really have a record of who actually owned it. So something like a blockchain could have helped, where there's this global ledger that has record of everything. So I think there are going to be a lot of real world use cases like that.
Awesome. So basically securing, protecting, and making sure that the data is reliable, basically.
Yep,
Sort of.
and available, yeah.
Yeah. So, and here, most of the community are fishing for stuff about testing. And Zach, for those who's not aware, so Zach Cole has been building a platform that will help you guys to spin up environments, test, and be able to reproduce the same type of conditions between two tests. So, Zach, could you maybe briefly explain to us if someone was new in blockchain, what would be the fundamental things that they should consider when they start a project, especially in testing a application that utilize blockchain network?
Yeah, so speaking from an application perspective, like as an engineer or developer, I think it's important to understand that blockchain systems are essentially distributed systems. So testing in the same way that you would test a traditional client-server application is not really the same in within a blockchain system, because every application and client essentially serves as like the client and server itself, and there are multiple machines that are taking part in this distributed system. So you need to account for latency between those machines. You need to account for the actual network and disparity between those separate nodes. And it's not as simple as just testing on a single machine against like a server. So I think that's probably one of the most important things that we need to understand when we're talking from an architectural perspective, when we talk about blockchain.
And I think you mentioned it's also a distributed system. So when you send a transaction, I guess potentially people should fish for other type of KPI. Just I did a load test and I sent 1,000 transactions. So I did 1,000 transactions per second. Is that a KPI that you can rely on, or should people consider other KPI?
It really depends on like you need to really take into consideration the size of the network. Because if you have two nodes in the network, or if you only have a single node, or if you have multiple nodes that are on a single machine, then your transactional throughput is going to be much higher because it's localized. So if you have a larger network of disparate machines, your transactional throughput is going to drop because transactions are broadcast to every participant within the network, or at least every validator.
Yeah, and so because you're aware of that, of the testing approach, what I'm pretty sure that I mean, if I'm digging, I mean, I know that I've been involved that, so I'm not gonna. But the thing is, if you start testing, pretty sure that I can spin up an Amazon machine, put my network there, or several nodes. What would be the challenges if I go in that direction?
Well, so if you're running on AWS, they're all on the same machine and the same instance. So there's no disparity between those two nodes. So there may be some logical there may be some logical separation, but there's no network latency. There's no distance between them geographically. So that's gonna have that's gonna skew the results, and it's gonna look like you're doing a lot better than you actually are, because you can't take the same approach as you would toward traditional application architectures.
So and also if I have let's say a big project, so if I use Amazon, I guess I'm spinning up the instances, and then if I want to reproduce the same test, I'm not able to do that because the entire blockchain network has data from my previous tests. They have been mined. There have been a lot of things. So I'm not able to sort of roll back the environment to the initial conditions. So that is a challenge, I guess. No.
Yeah, right, of course. So you don't have any control over that environment. So the results aren't necessarily going to be deterministic or reproducible. So some people in the blockchain space rely, or a lot of the projects actually, and Preston can attest to this, they're running a test net right now. They have public test nets in which people from the public, participants, can provide their own nodes within that test net. And that really helps kind of troubleshoot a lot of issues. But again, you have the problem of reproducibility and visibility into those observability, I suppose, into what those issues are. Like, how do you know what happened to cause a bug or a problem? How can you reproduce that in a way that makes sense, that's sane? Because you don't have any control over the participants, and there's no way that you can coordinate the public in a rational way to actually run tests that are going to provide you with valuable results. So we need something that's more deterministic and controlled, at least in our environment. And when we're conducting unit tests or any other like performance tests in general.
So Preston, do you involve the community when you do any test, or are you highly utilizing Zach for that, or a white block, I would say? So
we do a lot of our own testing, and we've been engaging with white block pretty often. The biggest test that we run is the test nets themselves. So we have a testnet called Topaz that's been out since just over a month, and this is a large-scale ETH2 testnet with the majority of the participants are community members. So that's really been critical for us, because without having the community run the majority, it's more like a centralized service. Like, we were able to unilaterally fix anything, but having this big giant test with a lot of unknowns, a lot of variables, a lot of things spread across the world has probably been the biggest thing. And then we can use whiteblock to validate some assumptions that we might have, and be able to reproduce those results. It's kind of hard to understand the problems that we have in a testnet, because we don't know who's operating it. We don't know who's operating on the other side. So we don't know what their environment looks like, or their internet connection, or anything like that. But for more, deterministic tests, as Zach put it, whiteblock's a solution that we like to leverage.
And so I'd like to also go on the direction of monitoring. And I know that Zach, you do a part utilizing Genesis for that. But
right.
I'd like to ask the question to David that is working at Dynatrace. So I don't know if you had sort of explored or look at what was the options possible to bring data or KPI that are available within a blockchain network and push it back to Dynatrace.
Yeah.
But this is a really interesting thing that I like to understand.
Yeah, no, absolutely. I had written a blog article on using Dynatrace to monitor.
Just some echo. I don't know if it's there's some echo. Yep. Go ahead.
Oh no.
I think it's Preston who.
Sorry, yeah, I dropped off and I'm back.
Okay, sure. Yeah, go ahead, David.
Yeah, no, that's fine. So I a year or so ago, I had written a blog article on utilizing Dynatrace to monitor blockchains. And blockchain, when you started today's conversation, you wanted to sort of like talk about it from a demystification standpoint. Like this stuff it's not black magic, as a matter of fact. Blockchains are basically, these are software processes that are running, sometimes they could be running in microservices context in a container. They could be running, just as regular processes on bare metal, if you've got little mining devices. So there's nothing really special or unique about the actual blockchain processes themselves. First off, is it okay if I share my screen? Because I can even show you some examples.
Of course you can.
Right.
Of course.
All right. Wasn't sure. It's my first time to one of these, so I just want to make sure it's okay. It's all right. All right. So let me share my screen here and give you guys an idea as to
what would be very cool, David, is that if you can publish the blog that you're referring to on the chat later on, that would be awesome for the one that are listening.
Absolutely, 100%. So what I did was, now I just did some really, really simple, quick examples just the other day in preparation for coming on to talk today. And so I literally spun up a couple of VMs in the Google Cloud, and I deployed Ethereum out onto them. So I've got these Geth processes running. So Geth is essentially, this is the process that is Ethereum that is essentially running that blockchain, doing all the calculations and everything like that. So from the Dynatrace perspective, we see that you would need to, if you're really, really want to understand the performance as to what's going on, and if you're talking about a closed blockchain environment. So this, obviously, if the blockchain is being distributed across multiple actors where you cannot install, say, one of our agents, it becomes a little bit tricky and difficult. There's other things that you might be looking at in terms of how you would be monitoring things. But for the processes that you're monitoring on your infrastructure, the things that you can control, what you can do with Dynatrace here is you can basically go into something like one of these, processes like this one, and here you can see that in this case we're pulling back a number of metrics. Now, some of the metrics that we pull back typically are going to be things that are, related to how much CPU is that Geth process consuming. What's the memory that it's consuming? How many worker processes are being spun up? What's the I/O like? If you think about it, the blockchain itself, because it's doing all of this crunching, it's doing it at a network level, it's doing it at a CPU level, it's doing it at a disk level. All of these metrics combined give you an idea as to how much resource is being taken up as it is churning through, doing all of its processing, all the things that it's meant to be doing. So if you think about it from the Dynatrace perspective, we will look and gather these types of metrics. We'll be able to combine it with metrics related to things, for example, here, quality. Here's an issue where all of a sudden this particular blockchain process, so this Geth process, we started seeing retransmissions showing up. So these retransmissions are network issues. And this gets back to what Zach was talking about, because Zach had mentioned that, when you start thinking about the distributed nature of blockchain, when these processes are communicating with each other and they're running on different systems all across different networks, when you run into a network issue like this, where you're seeing a bunch of retransmissions, that's absolutely going to be affecting the performance of that particular blockchain. And so these are the types of things that you do want to keep an eye open for. In addition to this, being able to understand what's going on within that blockchain process itself can also be very valuable. So what we've done here is we've actually piped out the output, the console of this Ethereum process, and we're basically created a little log file here for it, so that we have this geth.log file. And if I go in and look at this geth.log file, you can see here that there's additional information that Ethereum, in this particular case, is generating. So there's these provider, for example, here's some information about this provider and when it, an update code. If I scroll down here, you can see we're pulling out these hubs, these vendors, these fail counts associated with that. All of that information are things that you could turn into metrics to help you monitor that particular blockchain process. So you could literally create a counter from one of these log metrics. And what I've done here, just as an example, since we've been talking to our folks and our friends over at Neotys, who are obviously an excellent partner of Dynatrace, we were thinking about, or I was thinking about, what would potentially a Dynatrace dashboard look like if you were executing a load test against a blockchain process. And so this, I just sort of whipped one together really, really quick, just as an example. But here you can see that for this blockchain load test, we're pulling out a baseline that's looking at things like the CPU usage, the process memory for our Geth processes, our process IO. In this particular case, we're looking at some network round trip times, and then we're going in and we're looking at the metrics that are being written out into those log files. So here you can see we're pulling out that hub count, that vendor count. And so the idea here is that you could, look at the historical sort of results or the performance of your blockchain over a longer historical period of time, and then compare it to when you're executing it under a massive amount of load. And so there's all sorts of different scenarios that you could use this type of approach for. If you were trying to massively scale up a bunch of elastic services that were essentially micro containers that are all running these different Ethereum processes, these are all the different types of metrics that you could be using to help get an idea as to whether or not that performance is adequate, if it's going to meet your needs, that sort of thing. So that's just sort of like from my standpoint to answer your question around blockchain and from monitoring and metrics. Definitely, hopefully, this gives people some insight as to what's available to them. Blockchain is not black magic. It is something that is very tangible. It acts and behaves like other processes. It does have, as Zach pointed out, this distributed nature. So definitely paying attention to your network metrics is very, very important when you're trying to test the overall performance of your blockchain. How's that?
So Zach, I really like the approach, and I love the fact that you're pulling out data from log files. But I was thinking while you were presenting that, and I know that Zach from his platform, YBlock, is able to calculate tons of metrics based on logs, if I'm wrong. So Zach, is it true? Or do you think that, Zach, there are a way of bringing metrics that will show how those transactions are being processed to Dynatrace, similar to what David just explained us?
So what so Genesis allows you to plug in any analytics platform like Grafana or Kibana. Dynatrace can be used, Splunk can be used. All that stuff works and it just plugs in. But personally, what I do is I just dump all of the logs into CSVs, and then I post-process those logs in Python using Pandas or something like that, or Jupyter Notebook. And that allows me to control everything just by writing Python code. That's a lot of people hate that. I'm kind of like a masochist, I suppose. But it allows me to really kind of like control exactly what data I'm seeing, and I don't have to rely on some third party. Like, no offense to Dynatrace and all the third parties, love the third parties. I'm just like, more of a terminal window kind of a fella. So like that's my preference. And that allows me to just change the granularity of whatever I'm looking for based on Python snippet and Jupyter Notebook.
But I guess if you want to do that lively, because here you're extracting all the data, which is not live feedback. So it means you do a test of 2 hours and you're not able to make a conclusion after 2 hours. You have to get back the logs, process the logs, and then you can say, okay, everything went well. So is there a way to have the similar approach that you just explained, but lively?
One of you guys gotta, David, you gotta build it.
So it's funny you mentioned that, because what we were showing, it was actually running live. I literally have a couple of Ethereum processes running live. That data is being collected in real time. So as you're applying load to it, it is giving you back that data in real time. Now, you were mentioning, you like the idea of taking the log files and dropping them down into a CSV and doing a bunch of parsing with them. So from the Dynatrace perspective, you could, and conceivably, actually, we have a capability that allows us to monitor the log files in real time, so that you can actually set up specific rules or queries to look for values that are coming out of the log files, and then that allows you Dynatrace from the perspective can be used obviously for load testing and in combination with load testing, but it's also meant for operational analysis as well. And so the concept is that you could have it running 24/7, 365 days a year, doing its thing, analyzing stuff, and looking for exceptions. Like all of a sudden, if you start seeing some messages being written out into your blockchain log file that's telling you that there's a mismatch and there's an issue, that's something you want to be aware of, and you want to know about it sooner rather than later. So doing that real-time sort of analysis is definitely something that we bring to the table. And obviously for folks that are Zach, you were mentioning you like getting into the terminal and doing stuff that way. Totally get that. That's why a lot of the data that we are even providing, it's exposed out programmatically, so that you could be making programmatic calls using scripts to a Dynatrace API to look for those pieces of information that are relevant for what your particular needs are for monitoring that blockchain.
I can see that we have a special guest. It's he is usually hiking in Nevada and take a rides when any RV comes out of the picture. So he's been. If you don't follow Scott Moore and the Performance Tour, you probably don't understand what I'm saying. But he asked a ride from Scott Moore, and he was part of the show during several episodes. So it's James Pulley, without naming him. So James, how are you today?
Very good. The picture behind me is my front yard after 3 days of rain.
Gosh, I thought it was your bathroom. So okay,
No.
So James, welcome on board.
Sorry,
David, I just interrupted, but I wanted just to say welcome to James. So James has last year. Was it last year or 1 year and a half? I don't remember, 2 years maybe. You organized with Scott a meetup in Nashville with Zach. Zach, you were there, I think.
That was
Zach, you made an announcement that day.
I don't even remember. That was like 3 years ago.
Yeah.
So James is good friends of Mark. They organized, both of them, Perfbyte and News of the Dam. So it's really good to have James on board with us. So I would like to ask questions to Preston, and then if anyone wants to, of course, add things, just raise your hand, and we'll give you the power to open your mouth. I have that power. It's pretty awesome. But yeah, Preston. So how do you collect data and how do you measure things? So from the comment that Zach made, and from Dave, or the approach that David explained us a few minutes ago, it would be really interesting to understand how you guys do their testing, and how you guys are collecting metrics and making decisions.
Yeah, sure. So we use a lot of open source tooling for log ingestion, we write everything as fluentd compatible JSON, so this can be picked up by whatever tooling. Currently, we use Elasticsearch to ingest that data, so we can query it later and we can, figure out what's going on and for how long a problem has been occurring. For introspection of the application, we use open census tracing. So we have identified interesting methods and we're sort of capturing, sampling a small portion of these requests. So it's something like 1% of all the requests, we sample that and then write that to the backend so we can get a good understanding of how long certain processes are taking. For monitoring, we export some Prometheus metrics. So these can be collected by Prometheus and then, rendered in Grafana or alerted on with the alert manager or whatever. We have that plugged into, our on-call software. So if we have alerts going off, it'll wake people up in the middle of the night, which happens pretty often. So we're happy to have that in place.
Did you build your own agent in Prometheus to do that, to process your data, or is it a standard Prometheus?
It's the standard Prometheus. So we use like a pull methodology. So Prometheus will scrape all of the running nodes in the cluster and collect that data every like 6 or 10 seconds.
Got it. And if you were if you had to give advices or recommendation on things that our audience should pay attention on, especially when they work on the blockchain, what would be your, let's say, top 5 things that you should recommend?
Yeah, so number one is testing everything. So we have a huge, suite of different types of tests that we do. So we'll of course write unit tests for everything. That's one of our methodologies from the beginning, making sure we have great coverage of the code, making sure it works. Then we'll have things like end-to-end testing. So for every pull request that comes in, we'll actually stand up a blockchain and run it for 10 or 15 minutes. So if that still works, then you have the sanity check that you didn't break, the Genesis event, which is kind of hard to test as a unit test. We also do fuzz testing, which is really important. So using randomized inputs to find features in the code that maybe weren't covered by, or maybe they were covered by your unit test, but you have not thought of every possible edge case. So having fuzz testing can help you find that. We also do, and one of the biggest things that saved us so far is doing Canary testing. So when we have a new version of the application that we want to release to production or release as a candidate for users, we'll stand up the prior version alongside the new version as like a baseline, and we'll sample both of those on regular intervals with some production traffic and make sure there's no major regressions. So no spikes in CPU or memory, no spikes in message failure rate or RPC failure rate. That's been a really big one for us. And I think the last point I would put is that every change that's going into master has code review and sign up from someone else on your team, preferably someone who you weren't working with, so with limited prior knowledge, so that they can review it objectively and have another set of eyes on it.
Thanks. So I see that Scott Stevens is connected, and he made a comment about, and Mark as well, on R. So we had a pack members, Shivali Aparna, who made a explanation on the beauty of R. So have you heard about R Studio or R so far? Person? So R is So there is a tool called Tableau, which is quite powerful to BI, and R as a more like a sort of of course, an enterprise version, but also a free edition on the R Studio. And it's really a way of making some BI analysis based on data. So Mark, do you want to add something on that, or?
Yeah, I would just say R is really popular in the academic circles with quant heads, right? So quantitative analysis, statistical regression across stuff. So to like Zach's point, being able to look over the longitude of data for particular nodes, whether they're in tolerance or out of tolerance. So one of the things Igor brought up in the chat related to this was, if I own all the node infrastructure, all the peers that are part of the ledger, then I can monitor the entire system building a blockchain app if I own all those nodes. Whereas if you're trying to monitor just nodes you have that are part of a public blockchain, then you necessarily don't have access to monitor the internals of all those other nodes. But when you do, you might want to be able to say, all right, we've located certain parts of this distributed chain around different parts of the globe. And where you have leaders, or whether you're doing propagation within that part of the chain where the activity is happening. The idea that you'd want to say these nodes are always unhealthy because they're throwing an RPC error, because they have retransmission, or the network health is just not as good. We're going to find other places to locate those nodes or move them to different places. Then you could use R to look at the statistics sort of those errors, the occurrence of those errors, which is the same thing I think Preston's mentioning, or Zach, you said also, bring it down, throw it in a CSV. But you can publish and process a lot of that. When I've done R stuff, it's mostly for prediction. A lot of the predictive models can do stuff within R. So like Python and R, there's some stuff around performance, the seasonality of things that you have to get right to calculate. I'm trying to think of some of those predictive algorithms, pretty simple predictive algorithms based on a trend, and then you could predict where that's going to go in the future. People do that for financial reasons. We would do it for things like latency, error rate, what type of error, and when those types of errors might happen. So you're looking for, you would use R to figure out what's the probability of something not performing well. Like every day, every Thursday at such and such time, New Zealand's network goes to hell in a handbasket, for some reason. You'd find things like that and then say, let's not put any nodes down in that part because there's some other behavior or something happening. Bad weather in North Carolina, for instance.
but
Chaos in Hobbiton.
R is also great for simulations.
Yeah.
Okay,
Yeah.
so I never use for simulations. How do you use it for simulation?
So simulations are just mathematical models. So you can describe systems using R in order to so what I would recommend in like a quote unquote full stack, like distributed system development and testing platform type deal would be to run emulations within a practical network. In order to establish data sets that are indicative of real world properties, and then plug those data sets into simulations in order to run them over and over again at scale.
And just for further clarification on that, if I collect, for instance, users at a point in time, and then a resource measurement at a point in time, such as CPU at time 0 and users at time 0, I can use time 0 to correlate the two, and now I have a function of users at that time, or CPU for users or something of that nature, and that gives me a scatter graph through which I can get use linear regression. I can get a formula, and I can project it out.
Yeah, exactly.
And I can automate all that too.
Yeah, so that's the approach that we take when we're providing like testing services for different teams. Like we pretty much do what you described.
So my question about what you mentioned. So let's say I have to test. I have a customer say, "Hey, I want to implement blockchain," and he has a few numbers coming out from the hat. So he went to Philly, and there was a lot of rain. So the hat was full of water. And then he said, okay, now my projection is that I have a half a meter of rain, and I'm going to test that. But my question is, how could you basically do some sort of real user monitoring data, or collect data that will allow you to do a model? Because we are primarily, with a lot of folks here are performance testers. So we know, everyone knows that performance testing is about simulation. So if you do a simulation that doesn't reflect what's going to happen in production, it doesn't work to test.
Yeah, the challenge with a model is, at some point you have to have some assumptions that you build your model on, what you're monitoring. And as we all know, and I'm going to quote our famous performance tester, Donald Rumsfeld, there are known knowns, there are known unknowns, and there are unknown unknowns. And it's usually the unknown unknown which kills your model as you go further and further out on prediction, because you're not monitoring something that winds up being the bottleneck in your system. And then, of course, you add that to your model going forward. But ultimately, you get a mathematical formula. I'm working with a customer today, and these formulas show that CPU is really capping out at around 1,200 users, memory is capping out at around 986 users, so on and so forth. So we're getting different limits on scalability of resources. At some point, we actually have to test that and make sure that the observations that we have in the model match our model definition.
So I was more referring to about grabbing data from an existing blockchain network, and then from that data say, okay, from what I see here, we have this amount of nodes connected. They're sending that amount of transactions and whatever. So then if I need to retest these similar conditions, then this type of test needs to be achieved. So, from a HTTP perspective or other technology, we're quite confident because we know the approach. We have things that logs and bring all the assets. But for blockchain, it's from my end, I don't know, maybe there's an answer here and I'll have to hear about it, but it's a big question mark. So Mark, you raised a hand.
Yeah, I think it's important to look at different operations that are happening within the distributed ledger, right? So there's, to me, there's different types of finality that are needed in different ways. So in some ways, you may say, I need immediate finality, which means you need n number of nodes, or if not all the nodes, to immediately tell you, yes, I've committed this into the chain. Not only has it been generated as a block, but it's been propagated. And Zach and Preston, you guys can correct my language. I'm much better than me. But one is needing immediate finality, which means it's almost like it's a synchronous activity across the ledger, I think. And so there, all it takes is one node to have really shitty performance, and then the entire transaction suffers. Whereas a probabilistic type of finality means I can commit it into the chain and then trust that the nodes will propagate that asynchronously. I don't know if that's correct in thinking, but that's in terms of commit performance across all of the nodes in the chain, in the ledger, so that then all it takes is one bad node or to basically slow everybody down. And forgive the pun or the expression, you're as fast as the weakest chain in the link kind of thing. Sorry. Then read performance is very different, right? In terms of what you're asking the nodes to give you data, which is much more latency related in terms of network or RPC and retransmissions. So I think understanding how data moves within the ledger or gets added to the ledger, if I think about it that right, what's required to check in from the node peers to confirm that depends on what operation you're doing and testing for. That may be critical to an actual client, an actual end user, or piece of machinery that's saying, I need something to happen fast enough as I'm generating a block and then propagating it across the ledger. And again, I'll defer to Zach or Preston that know much more about the mechanics underneath the covers on that.
So Preston and Zach, where can we get the right data that will allow us to build that workload model that we should apply in our test? Do you have any insights to share with us?
I would recommend using the Genesis platform from Whiteblock at www.whiteblock.io.
That was a recorded voice. So. Preston,
Yeah, it's the bot I made for webinars.
If I can interrupt, Zach, just to talk about it a little bit, there's a lot of variation now. If you look at things like from Genesis, there's Hyperledger is another one that's changed the architecture. Like the blockchain concept is evolving from where it was 5-6 years ago. So some of the language I just use is probably quite dated compared to new ways that a distributed ledger is working, right?
Yeah, so primarily what's happening, I mean, at least I could speak for the Ethereum space, and Preston could speak better than I could. The Prismatic Labs client is the leading client for ETH2. I mean, but primarily the shift is from proof of work to proof of stake. And that model shifts a need from computation specifically to more economic incentive models. So people stake in order to participate in the network. It has much lower computational overhead than proof of work does. Nobody's going to say anything about Bitcoin mining taking up more electricity than, you know, your Christmas lights or whatever they're complaining about. Like, you know, it's going to be more economic incentive models now. So, and I'll let Preston share more because the Prismatic Labs guys are the best.
Thanks, Zach. Yeah, so what we're really interested in for this kind of stuff is, I guess, like block propagation is still important, and also propagation of all of the validators' attestations. So we have significantly more messages being propagated through the E2 network than we do with the Ethereum 1 network, even before there are transactions. Because we have every validator that exists will be performing at least one action every 5 or 6 minutes. So adding all these together, especially when there are tens of thousands or hundreds of thousands of validators, is a really difficult problem, and also really difficult for us to collect data on, especially when you don't own all of the nodes in the network. What we do currently is when we receive a message, we'll estimate the time that, you know, based on the protocol, the time they were supposed to send it. So if we're talking about blocks in proof of stake, they switched from, you know, this hash rate model where you had to compute this, you know, difficult puzzle that was at least this difficult, to a time-based model. So every 12 seconds, someone's going to produce a block. It's randomly decided who does it. But if we receive that block 3 seconds after we know that it was supposed to be created, we can monitor and track this and kind of estimate how the network is doing based on those kind of parameters.
So actually, Preston, on that topic then, so the way that the different nodes communicate with each other in, you know, for blockchain, it is basic, it's straight up like HTTP REST traffic, right?
So for like the peer-to-peer communication, it's using like more like a pub sub model. So you'll subscribe to a particular topic. You know, if I'm a validator in a certain committee, I need to talk to other validators in this committee, but I don't need to listen to everyone. So I only subscribe to that kind of topic.
Yeah, but the actual network connection itself is...
It's like a TCP connection, yeah. It's not RESTful or anything like that.
Okay. So if the network connection between these different nodes is just, you know, straight up sort of TCP, then would it make sense, and I'm just doing a mental exploration right now because I haven't tried it myself, but would it make sense? What if we had the ability to do some proactive synthetic tests that allowed us to get back, you know, a piece of data or, you know, a specific response from that remote node, as well as to give us an idea as to what the network latency is when we actually make the connection to that node? Is that the type of thing that then, if we could, one, proactively do that and then bubble that information all up in an aggregate source, would that be valuable?
I don't think that's going to be valuable within public networks.
Yeah.
Because that's going to require the node to expose some sort of its information to the outside world. and that can present an attack vector. I mean, so ideally that would be valuable, but also you have to keep in mind that you're connecting to a computer that you don't know, run by a person that you don't know, that you'll probably never meet. And we have to assume that all of these networks are hostile. So we're developing and designing these systems for communication across inherently adversarial conditions.
Yeah, but if you're talking about private blockchain, for example, where you know it's a less hostile world, at least you controlled, or at least who is participating to the network.
Sure.
Could
and
you
that's a
add
different
that
story.
Okay.
Yeah, maybe it's a limited blockchain for brewers and marijuana producers or something.
Or non-criminals. It could just be a post office.
But what would you say criminals? I don't get it.
Not that we're suggesting brewers are criminal. Yeah.
Well, it depends on what decade you're talking about.
Mark.
I was going to say, to Preston's point, it sounds like there's already something within sort of, we know every 12 seconds, a time-based versus puzzle-based or complexity-based. There's already some metrics around how much time before or after, I'll say after, latency-wise, every 12 seconds you create this, and then it's 3, 4, 5 seconds where another validator receives that. Is that flow through a separate set of topics as sort of are there already some metrics that are there in terms of network health that's happening already that we would just need to harvest from a log message or harvest in another way?
Well, probably when you're establishing a handshake, you're exchanging some information with a node that you're connecting with. Yeah. So there's going to be some data that's inherent to that handshake that's being established. But beyond that, you don't want to provide any additional information, I mean, in a public network.
Right. We get the arguments all the time. It's like, I don't let you monitor X, Y, and Z in production. It's like, this is not PII, PCI, it's not privacy data, it's not anything. But to some extent, Zach, you're right. People are like, no, I completely lock down my node. I don't want anyone to even know what platform I'm on. I don't want you to know how many CPUs I have, what kind of ASIC I'm running, any of that kind of stuff, right?
Yeah, because even like peer discovery presents an issue. Like within like a Kademlia-based DHT, there's like Eclipse attacks, right? Yeah. How do I know that the information that I'm receiving from the outside world is valid? Because you could surround my node with your own nodes that you control that will tell me one version of something else when the real world is not that way. And I guess a good analogy would be Facebook, people in their echo chambers.
Yeah, but I'm thinking more about because if you just start testing, you're not testing on a public network. I mean, at least not when you start. You do at least in a controlled environment because.
Right.
Yeah, go ahead.
I mean, if we're using like with Genesis, right, we have control over that. It's safe, it's secure. Like we can implement whatever we'd like for testing purposes only. And a lot of clients have like their own testing configuration. I know Prism does, and Geth does as well.
But I was thinking when I especially here because it's more like a network or exchanging data and in a secure manner. And now with load testing, what I more and more try to push people on that is that, hey, you should definitely consider at one certain stage of your test to involve chaos monkey or failure testing or whatever it is, break things and see if you're impacting, and how your architecture, how your system behaves when there's something wrong. Do you think, Preston or Zach, this is a question to you both, do you think that there would be a way to include that chaos engineering approach within a blockchain testing? But I'm not talking about public testing, public network, because obviously you're going to try to break the so that will be considered like something weird. But in a controlled environment, do you think that it could bring value?
I'll let Preston answer because I'm going to say yes because I'm selling a product that does stuff like that. So,
yeah, I mean, it's definitely valuable for us as developers, to understand how we can improve the performance of our application, because like even though this is meant for a public adversarial network, our users are trying to reduce their bottom line as any way they can. So if we can shave off, a few routines here and there, or if we can reduce memory usage, that means they can use cheaper hardware. We're interested in trying to find better ways to do things, and also being able to come up with well-informed recommendations. So a question we get all the time is, what kind of computer do I need to buy to do this? And without having this kind of analytical data, we're guessing at that point. So it is valuable, I think, even in a public network.
Okay, got it. And so you, Zach, you mentioned that you're doing it. So how I know that you're doing bringing latency, packet loss. You can put bit distances between in the network and so on and so forth. But how do you introduce failures?
Well, so when we're talking about failures in blockchain systems, we're generally referring to like Byzantine failures. So that means that a node in a network performing in a way that it shouldn't, or just becoming unresponsive. So in most cases, what we can do in order to implement those Byzantine-like failures is implement network partitions. Prevent certain groups of clusters of nodes from communicating with other clusters of nodes, or just completely cut the network in half and see what happens. So that's generally the best way to test failure, because you have a distributed system. So to some degree you have redundancy, but then it becomes a security concern that should that amount of nodes drop to some level, how is the network going to perform, and what is going to happen in terms of like transactional like success and consensus. So we want to test Byzantine failures in relation to consensus, and that's what we would generally do, and that can be implemented through latency, high degrees of latency, packet loss, significant degrees of packet loss, or just network blackout conditions entirely.
Okay, good, thanks.
Or high load. Yeah, high load as well. We also use Neoload.
Of course you do.
Let me shill Neoload for a second. Talk about how important it is to load test, because that significant load can present the same constraints that a network outage would present. I mean, it doesn't matter at a certain point if I'm being flooded with packets, I'm DDoSing myself.
Yeah, but if you have a load, but in the same time you have, let's say, part of the nodes are disconnected, or I don't know, like you said, the Byzantine.
Well, if the node reaches a certain threshold, though, it doesn't matter if like there's network outage or not. If it takes me that long to process those incoming packets, it has the same effect as me not being able to communicate with that node whatsoever, because like Preston said, we're switching from this computational based model to something that's more time based. And if you know anything about computers, time is an illusion, right? So whenever time is involved, you're going to be very sensitive to these things. And you have to really make sure that you're testing performance and you're testing your throughput and you understand how your system works under those failure conditions.
Do you think that the blockchain network or people involved in blockchain, they are not educated in performance testing?
I don't think it's blockchain. I think a lot of people in the world don't really do a lot of that. A lot of people, like a lot of developers, are kind of flying by the seat of their pants, and they're just, let's go live, we'll figure out how it's going to work. This is a story that all of us are familiar with, I'm sure.
Yeah, but I thought that we have the cloud, so we have not to worry about performance anymore. The cloud will help us to do that. This is what James told us a few weeks ago, I remember.
Well, I don't think that's true. I mean, especially in the blockchain space, we want to be like, we have this whole cult of decentralization. And if all of the nodes are running in AWS, how decentralized is that?
Yeah. And furthermore, if you're relying on a precision clock, how do you handle the clock jump problem inside of virtual machines?
Yeah, like time drift. Exactly. Yeah. So
I think there's two challenges, as Zach points out. One, there's a lot of performance and load testing that really still lives in the application layer, looks at queries, look at code profiling. I mean, from a Dynatrace perspective, you can look absolutely inside everything that's running and detect those anomalies and bottlenecks that are more application level. Whereas a lot of the bottlenecks, a lot of testers, performance testers, aren't as familiar unless they get into chaos engineering with these network level types of impairments, bottlenecks, anomalies, and also having control over the network is something that I see a lot of performance testers generally don't have access. They're like, well, here's your lab, but go ahead and run your load test. But you don't. You're not a network admin, and they now with security concerns, they lock down that network. It's an ephemeral network, so even if it were there and then disappeared, so I think there's something about infrastructure-wise to be able to do performance testing of a distributed ledger. Igor asked also, what's the difference from, is really blockchain the same as testing microservices? And I'm like, yeah, if your microservices are highly distributed and highly interdependent, then even microservices testing generally with a pub sub model, you could be looking at the similar types of network impairment affecting an entire network of microservices. Whereas in blockchain, you're really looking at different validators and nodes within the network in the same way.
Yeah, but I think it's even worse because there's a notion of I have some data set that I use for test one. Oh shit! How do I? Oh no! I will stop that. Yeah, because this is nightmare. I mean, if you run a test, the data has been processed everywhere, and then it's impossible to go back. So it's just a big problem. And we've discussed it several times. Data is expensive, and if you have an environment that you're not able to restart or do things, it's going to be just a big pain at the end of the day.
I'll give a shout out as well. One of the things I pasted in the chat with everyone was the peer performance interview that David did back on a podcast. So it's from quite a while ago, but it's still really relevant about how, again, if you're not familiar with the core fundamentals of network performance, I mean, you've got to beef up on that before you're going to start wandering into all the different networks that Zach and Preston are talking about in terms of specific ledger performance or the distributed nature of a ledger performance. So retransmissions, retries, done. I mean, if you don't understand the core in terms of network distributed stuff, that's a great place to start. And David, you covered a lot of that right from the get-go in that podcast episode.
And similar, I mean, testing environments, if you mentioned about, you use that network to test, but this network is probably empty. There's no traffic. So basically you're testing something where there's no package going on in the network. So you're like in a virgin network, everything is cool. Even if maybe you can face some issues with security. I mean, maybe you don't have the rights and so on, but still, this network is fully empty. You can do whatever you want. What happens from the moment the network has been utilized at 50 or 60%? That are type of questions that could pop up in your mind if you know
and
network problems.
That's an entire different class of tools that we usually don't touch as application performance testers.
Right.
Tools from Ixia, Spirent, these types of companies that do traffic-based load generators that can generate millions of MAC addresses, IP addresses, and flood an entire network for testing purposes.
I heard that someone pushed a project that could do that with Neotys, but I don't know who. But there's someone who does that. All right, so it's 8:08. We've passed the hour, to be honest. And I know that usually when we start the conclusion in our pack meetup, it takes almost 15 minutes to finish. So we have a few minutes to go. Before we continue the pack meetup, I just want to give you some information. So we are in France, and I know in France we have so many vacations. We are working one day per week. The rest is for weekends. To make the point, tomorrow is bank holiday, and if you're looking for the recording of the meetup, don't be a bit patient because tomorrow it's going to be sunny, and we're going to do some barbecues, and probably I won't be able to push the recording. So I will probably publish those recordings from next Monday. All right, so that was my small comment about where and when you will have the recording of that meetup. So let's continue the discussion. So David, you've been involved in the performance cafe with Brian Wilson, I guess, and Andy, I guess, on that topic. So did you share the similar type of assets that you just mentioned to us at the beginning of the meetup, or did you explore other areas?
No, for the most part, it was pretty consistent with what we had talked about with them. From the Dynatrace perspective, especially when we were talking about the blockchain, like I was saying, blockchains are not mysterious, they're not magical, they are software processes. And what Dynatrace does and does really well is, it automatically discovers processes, it automatically baselines the performance of these processes, it automatically detects issues with these processes. Where I think, one of the things that, definitely I think, Preston and perhaps even Zach, might want to, we could have a side conversation about this or a public conversation about it, is the idea of, better automating a lot of that testing that you're doing. So one of the things, since Dynatrace, when it discovers all of this data, its AI engine is constantly crunching it, looking for anomalies. This data is exposed out programmatically, so that what you could potentially do is think of Dynatrace almost as a quality gate, so that you could build into your processes essentially a check to Dynatrace to say, is this particular build or variation of this particular blockchain, does it have any issues with it? If it does have issues with it, then push that build back to the developer and tell them what the problems are. If it doesn't, then push that on to the next stage in your development. So you start to include Dynatrace to help better automate your code pipeline, eventually getting to a place where you could conceivably be thinking about doing green-blue type deployments and automatically rolling back a blue or a green deployment, depending upon what's being observed in terms of the behavior of that blockchain. Definitely those are things that, I think are important. I like to talk about those types of things.
But by just explaining what the approach and so on, I thought, and by knowing how Zach is working in the architecture of Zach's product, I thought that, hey, Zach could have a partnership contract sent over to David so they can sign and start collaborating and including Dynatrace One agents in the platform. That would be pretty awesome.
Yeah, let's do it, David. I'm down.
Let's talk.
So Preston, what is your approach on that? Would you utilize an APM or a solution such as Dynatrace that will give you more insights on network, or you're more relying on the logs that you mentioned before?
Yeah, I mean, we would definitely consider it. We have solutions for just about everything that was mentioned already. So we do, as I said before, we do the Canary deployments. So we have the, our deployment strategy in place, and we have introspection and application level monitoring. I think Dynatrace gives a better view of that, a more reliable view. So, we could consider that, but yeah, I guess we haven't looked into it too in depth yet.
But from your expertise on the blockchain industry at the moment, I guess on the observability and telemetry and APM world, I think there is no clear solution that has positioned themselves on that stack. I'm pretty sure that that's the current stage. I am right?
Yeah, that sounds right.
Okay. So it's like a totally virgin market, as I think everyone is watching. It's like watching themselves say who is going to start, and then everyone's going to jump in this swimming pool.
Sorry, I just want to interrupt for a second though. It's interesting because Preston, earlier on, you had mentioned that you guys were using some components of Open Census, correct? Yeah.
Yep.
And so, yeah, so it's interesting because you mentioned that, obviously Open Census is right now, there seems to be a shift in the industry as Open Census gravitates more towards open telemetry. And so the concepts of open telemetry, I think, are actually going to make some of the conversations, especially at this, from a blockchain perspective, going to make things very, very interesting. Because if you have, applications that are being built with open telemetry built in inherently into them, then the ability for you to do that distributed tracing across those distributed systems, at least there's an opportunity in some cases to be able to share back and forth, some of this trace information, even if you don't happen to necessarily own that remote node. So there's certainly some interesting things that are happening in the industry that may make things, much more open in the future. And I think open telemetry is going to be a big part of that.
Okay, great. So I guess we have to test that. I guess there's no other word. So I'm looking at the time. It's 1:15. So usually we take around 15 minutes to conclude. I would like to get you guys to at least Zach and so to provide your thoughts when you start the conclusion on what would you test, or what would be the approach when you test a blockchain? I'm not referring obviously in unit testing here. I'm saying that I have built something and I'm going to connect my apps to that network. What will be the process to validate the basic stuff? If someone is new on blockchain, how could we help them to guide and to save time by having this? And then we can following the conclusion of that. But I'm really looking for that. I think there is a lot of people that are part of this meetup that look at the blockchain network like a black magic, like David mentioned before. So I think we have to demystify that for sure. So Zach, you can start.
I suppose make sure you're building on the right platform would probably be one of the first things. But before that, identifying your use case and what are the needs specifically of your application. Because that'll help you narrow down which platform you're going to build on, which protocol you're going to use. Of course, I think you should probably use Ethereum. It's the most mature. So in that regard, I would just begin to use some basic tooling. I mean, I would, aside from shilling my own product, Genesis, you could also use something similar to like Truffle, which allows you to spin things up locally and deploy smart contracts. So those are likely going to be smart contract based. So I would just make sure that you have that identified.
And you mentioned about building the right tests. So how would you recommend people say how to detect what would be the right test?
How to figure out what would be the right test? Yeah, I guess depends on what issues you're having exactly. I would say creating like a CI/CD pipeline. And what I would do is connect it to Genesis, and I would test and define my environment within a YAML file. And then when I'm making changes to my code, I would continually test to make sure that my processes are performing the way that they're expected to. So I would recommend a CI/CD approach, but make sure that you keep in mind that these are distributed systems. So if you want to perform practical functional tests of distributed systems, you need to perform those tests within a distributed system. And I think that's probably the most important thing. And running tests on your local machine just isn't going to cut it.
So we definitely have to do like a cookbook session together to show how to do that. That I think will be very helpful for people that are quite new in the blockchain industry. Preston, what would be your recommendation, best practices, things that people should really pay attention if they have to deal with a blockchain an application that will interact with the blockchain network? What would be your approach, and maybe to may introduce a few KPIs after that?
Right. So building applications on blockchain is a very different paradigm from what we're used to, since the blockchain is immutable. You can't. It's very hard to upgrade or modify any existing application on the blockchain. So I think if you're looking to build things at the application layer, invest a lot of time into the design of it and making sure that everything is clear through documentation and whatnot, so that when you go for a security audit or review, that makes a lot more sense. And for users looking at it, they can read the code and whatnot. And as Zach said, try to choose a platform that is more mature, kind of see where the users are and where the network effects are going. Each blockchain out there sort of targets for specific needs. So as you're evaluating where to build your application, just keep in mind that what the roadmap looks like and what the development looks like, and the loose leadership of the community and sort of how the community comes together. So yeah.
And maybe before you build the app, maybe you know that you're going to interact in a distributed network. Maybe try to figure out how this network will react with the quantity of data or things that you interact before you start plugging your app, because I think depending on how you're planning to deliver your app in that network, you could definitely change the behavior. So do you have any insights on that?
Yeah, that's true. One thing to consider is, at least at the layer 1 protocol level, can your application be supported on this platform? And if not, what are some other solutions you can use? I think one of the biggest things we need to do is just like take a step back and ask yourself if building it on the blockchain is even the right solution. A lot of people we've seen in the last few years try to sprinkle blockchain on an idea and hope it's valuable, but they find out that putting in a blockchain doesn't make the idea any better. It actually could make it more difficult to do. So make sure you really evaluate and validate your idea before even considering putting it on a blockchain.
Yeah, makes sense. Makes true sense. Yeah. James.
Yes.
What would be your recommendations to our audience about if you had someone, a colleague, some of your colleagues to say, "Hey, I have to test the blockchain network. I don't know what it is." What would you tell to him?
Well, first of all, I have him call Zach for a testing tool. So that's right off the bat. But there is something that is missing on the blockchain side of the house that we have on other infrastructure pieces. We have for IoT, we have for database, we have for web, for virtualization, is we don't have a kind of a vendor neutral benchmark yet, from like TPC-C or SPEC or one of those organizations. We have some academic benchmarks. We have some applications that kind of serve as benchmarks. But it's very difficult for us to compare one blockchain to another in a static model. Or even if we look at TPC-C, that has a growth model in it for how large your database is. We need a model for how large the blockchain grows for how the benchmark is run. And that's something that's probably going to come at some point in the future as blockchain technology matures. But in the meantime, you're testing one off. It's still a question of message and protocol and monitor and resource. You can exhaust a node, you can monitor it to its infinite degree and find out what happens for nodes you control, to the issue of public versus private in that case.
Makes sense. So Zach, when should we start doing the benchmark for the market?
Tomorrow.
Okay. So 9 a.m. tomorrow. Okay. Tomorrow is bank holiday. I was supposed to do Barrow. Shit.
I meant the French tomorrow, which is next week.
So David, what would be your recommendations if you had someone say, "Hey, I'm going to build a blockchain network. I have Zach is involved, so I know pretty much how to test, and I've listened to the meetup, so I have some ideas. But how could I have the right observability approach if I deploy that into the real world?" You're muted, David. David, you're mute. Yeah.
Mute. There we go. I want to answer this in two ways. I want to answer this in two fashions. So, obviously, as per what James mentioned, if you control your all the nodes in your blockchain, then from an observability standpoint, definitely, the types of things that we showed today, that we talked about today, are all on the table. You monitor the health of those processes. You baseline the performance over time. You can, look for key metrics that are being written out to those log files and expose those out and use those to manage and monitor things. But the one thing I don't know that we actually really talked about a lot today, which I think people should keep in mind, is at the end of the day, the blockchains exist to provide some functionality that ultimately interacts with some end user or some end process. Especially if that blockchain is attached to anything that reaches eventually functionality that impacts an end user, then you should also be thinking about, things from an end user perspective and monitoring from that perspective, so that when a user is interacting with some UI, some interface that eventually talks to some component that then talks to some blockchain or some ledger, that you should be able to understand all the way from the moment that user makes that interaction all the way back to the point that it's touching that blockchain, what also is involved in terms of, anything that could impact that user's experience or performance is something you should keep in mind.
Awesome. Thanks, David. I was watching Mark, and I just saw that Mark had a special guest for the conclusion. So maybe your guest could contribute to our meetup.
That's Amber. She's actually very interested in more of like ASIC performance and like tuning, crunching machines. And particularly because they have sensitive sound. They're very loud. They have the big fans that like, the ant miner kind of stuff. Yeah.
Is she for or against ProgPow?
I'll have to ask. Of course, I have to translate it into dog, and that'll be.
So have she tried any Akamai stuff to automate everything?
No, she's mostly interested in salmon treats.
Okay.
That's about it.
So, Mark, what will be your recommendation? Things you would like to share with our audience?
One, I would say, don't be afraid of blockchain generally, right? It's not as foreign as you might think. You might be more. We have great resources to reach out to, but I think the fundamentals of a distributed understanding of network distributed systems, if you get into the things that are crunching, looking at algorithms that are doing the crunching, the actual CPU optimizations that are happening within a node, that's a whole other ball game and very unique for each application as to how those other things are done, both from the peer perspective and from the node perspective for different types of chains or ledger platforms. But yeah, even if you don't have access to stuff, that's the big question I think I've learned from Preston here really is, when you're making that decision, is this something that I really want to rely on a public distributed chain to do it? Or is this something that's a different choice? If you're architecting for performance, you're going to want to pull in experts, right? Different than what James and I have talked about, or James brought up earlier, which is, hey, we built something, now let's go test it to see, if it matches what we're expecting. If you're really starting with those initial questions of, hey, are we architecting this application? Should we be using blockchain at all? What are the performance characteristics for scale? Then you need to have somebody that's already been there, already been in the nuts and bolts of how a distributed ledger system works. It's very different than grid computing, very different than microservices, and that dependency is different to manage as well. So that's my recommendation: is start asking those questions early and bring in the expertise early to make those decisions for architecture.
All right, thanks, Mark. So yeah, I agree with you. First, so you don't be afraid. It's just another stack, and from the moment you invest yourself, you discover things, and then you open up Telegram, you go to Yblock and say, "Hey, can you help me out, guys? I'm completely lost," and usually they're quite reactive. But all right, so it's another pack meetup. It's the number 8 that we did tonight. Next week we have another pack meetup. It's gonna be our last because we said we're gonna finish the lockdown with the end of May. Maybe we thought that finish with a number 9 doesn't make sense. Maybe we're gonna add maybe a surprised meetup in June. You will see. So follow us and you will see. But next week we already know the theme. And I'm pretty happy to provide it almost not last, but it's going to be about browser-based. A lot of things is happening on the browser, a lot of JavaScript involved, a lot of rendering, a lot of concept about things happening on the browser, the DOM and so on. Many people say, yeah, I'm going to use browser-based testing. Other one says protocol-based testing. There is obviously 2 different approach of dealing with this. So I know that it's a hot topic, and many people are been frustrating testing modern, simple page applications. So I think it's going to be a really good discussion to have. And by the way, Mark Tomlinson did a pretty good presentation on our last Pack to the Future about web performance. The best 2 things to consider.
I was going to say, isn't it a Beatles reference? The number 9.
It is.
Isn't that the bad number 9, number 9, number 9? Yeah.
It is, but that's why we said there is an IP on that, so that's why we have to continue to number 10. So, yeah,
exactly.
But 10, there's a problem. There's a Pearl Jam did 10 on that's a shish.
Yeah, you're right.
So 11 then. 11 shish is Stranger Things. Shish. Okay, so we're gonna continue forever. Oh, I'm stuck. So whatever. All right, thanks everyone for being here. Thanks again for all of you, Zach, David, Mark, Preston, James. Thanks to all the comment. I hope that you learned quite a bit, and now I'm excited because I definitely need to do a cookbook with Zach. So I'm excited to do that. So we have to explain things, real live things, so people could have a better understanding. Thanks again. Enjoy your end of the day. Enjoy your weekend for those who's living in France. So sorry for the other ones. Enjoy Thursday, and see you soon.
Thank you. Bye.
Henry.
Thanks.